Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 2.1. Number 1. The diagram on the right shows a part of the graph fx equals to x squared minus 4x plus 3. A. From the graph, find each of the following. Number 1. Limit when x tends to negative 1 of fx. So look at the graph. When x tends to negative 1, we got this point, right? From the left and from the right of negative 1, they all tends to 8. So the limit of fx when x tends to negative 1 equals to 8. Number 2, limit of fx when x tends to 0. So when x equals to 0, from the left of 0 and from the right of 0, they are going to 3. So the limit of fx when x tends to 0 is 3. Number 3, limit of fx when x tends to 1. So when x tends to 1, from the left of the graph and from the right of 1, we see that tends to 0. So the limit of fx when x tends to 1 equals to 0. Number 4, limit of fx when x tends to 2. So when x 2, from the left and from the right, that tends to negative 1. So the limit of fx when x tends to 2 equals to negative 1. Number 5, limit of fx when x tends to 3. So 3 here, from the left of 3 and from the right of 3, they all tends to 0. So the limit of fx when x tends to 3 is 0. Number 6, limit of fx when x tends to 4. So when x tends to 4, we will see they should going toward 1 value. So we can substitute the 4 into the fx, which is x squared minus 4x plus 3. So we get 4 squared minus 4 times 4 plus 3. So we get 16 minus 16 plus 3. So we get 3. So we will see when x equals to 4, from the left and from the right, they are all going toward 3. B. Find the possible values of a if limit of fx when x tends to a equals to 8. When fx equals to 8, this is the place. So we will see from left and right, they are going toward 8. And same thing on the right, from the left, from the right, they all tends to 8. So we can do substitution of a into x. So we change the fx into x squared minus 4x plus 3. Then, since the limit of x tends to a, we can substitute the a into the x. We get a squared minus 4a plus 3 equals to 8. So we can solve this quadratic equation by factorization equals to 0. So the first factor equals to 0, we get a equals to 5. And second factor equals to 0, we get a equals to negative 1. So these are the possible values of a. C. Number 1. Determine the gradient of the tangent function dy dx of the graph by using first principle. So tangent function means the dy dx. So starting from fx equals to x squared minus 4x plus 3. Then for the f when x plus del x, okay, we get x plus del x squared minus 4 times x plus del x plus 3. So from here, this is actually the fx plus the very small difference of fx. Then when we expand this bracket, we get x squared plus 2 times x times del x plus del x squared minus 4x minus 4 del x plus 3. So we get 2 equations. And to get the del f or the dy dx, we use second equation to minus the first equation. So fx minus fx, we left only del fx on the left. And on the right, we get x squared minus x squared, then 2x del x plus del x squared, and minus 4x on 0, and then minus 4 del x, we copy back, then plus 3 minus plus 3, we get 0. So we will see, after we factorize the del x, we get 2x plus del x minus 4 in the bracket. So if you want dy dx, or the f prime, which is actually equals to del fx over del x, so we move the del x over to become divide, and we get 2x plus del x minus 4 on the right. So the f prime is actually limit of the 2x plus del x minus 4 when the del x tends to 0. So when del x tends to 0, we get 2x plus 0 minus 4, which is 2x minus 4. So this is the tangent function using first principle. Then number 2, determine the gradient of the tangent at the point 4, 3. Since we have the gradient function f prime x equals to 2x minus 4, so to get the gradient of the tangent at point 4, 3, we use the x value 4, substitute into the gradient function. So we get f prime 4 equals to 2 times of 4 minus 4, so which is equals to 4. Question number 2. Find the value of each of the following limits. A. Limit of x squared minus 6x plus 9 when x tends to 0. So just an algebraic expression like this, we can substitute the x equals to 0 inside, and we get 0 squared minus 6 times of 0 plus 9, we get 9. B. When the limit of cube root of x to the power of 4 minus 2x to the power of 2, when x tends to 2, so we can do substitution when x change to 2. So we get 2 to the power of 4 minus 2 times of 2 squared, and cube root the answer. So we get cube root of 16 minus 8, so we get cube root of 8, which is 2. C. The limit when x tends to 9 of 9 minus x over x squared minus 81. So if we substitute the 9, then we get 0 over 0. So we cannot straight away do substitution. But we can see in the denominator, we can do factorization. X squared minus 81, we can factorize it become x plus 9 and x minus 9. So we see 9 minus x and x minus 9 here, which is actually times negative 1 here. Alright, so we times both negative 1, so that the first negative 1 times in, I get x minus 9, and then the second negative 1 here, leave it outside. Alright, so we get negative x minus 9 over x plus 9 and x minus 9. So we see common factor up and down of the fraction. So x minus 9 and x minus 9 is the common factor that we can cut off. So after we divide, we left 1 on top. So therefore, we get negative 1 over x plus 9. So now, let's try to substitute 9 for the x. So we get negative 1 over 9 plus 9, which is 18. There we go, we get the limit of the function when x tends to 9 equals to negative 1 over 18. D. The limit of x squared minus x minus 2 over x minus 2 when x tends to 2. So, if we substitute the 2 inside, we get 2 squared, which is 4, minus 2 and minus 2, we get 0. over 0. So we try to do factorization to see whether we can cut off the common factor. So on top, x squared minus x minus 2, we can factorize it by x minus 2 times x plus 1. Then over the x minus 2, so we see common factor again, which is x minus 2 and x minus 2. There we can cut off and left only 1 down here, x plus 1 divided by 1, then we get only x plus 1. So now, if we substitute the limit of x tends to 2, which is the x equals to 2 here, so we get 2 plus 1, which is equals to 3. E. The limit of x cubed minus x divided by x minus 1 when x tends to 1. So when x tends to 1, we straight away stop in. We get 1 cubed minus 1, which is 0, over 1 minus 1, which is 0. So we try to do factorization on top. So take out the x, factorize out the x, we get x times of x squared minus 1. And x squared minus 1 can be factorized again, right? So to completely factorize, we get x times of x plus 1 and x minus 1 divided by x minus 1. There we have common factor, x minus 1, x minus 1. So after cut off, we left only x times x plus 1 for the limit, okay, when x tends to 1. So now, if we do substitution of x, we get 1 times 1 plus 1. Then we get 1 times 2, which is 2. F. The limit of x squared minus 7x plus 10 divided by x squared minus 25 when x tends to 5. So we try to do factorization. So x squared minus 7x plus 10, we can factorize it by x minus 5 and x plus 2. And x squared minus 25 become x plus 5 and x minus 5. So we can cut off the common factor. So we get x minus 2 over x plus 5. Now if we substitute the 5 inside, we get 5 minus 2 divided by 5 plus 5, which is 3 over 10. So this is the limit of the function when x tends to 5. Question number 3. Determine the limit value for each of the following functions. A. Limit when the square root of 1 plus 2x minus the square root of 1 minus 2x divided by x. So we see irrational numbers here. So when we substitute the x equals to 0 inside, we get 1 minus 1 divided by 0. So we get 0 over 0, which we cannot determine the value. So what do we do here is, when we see irrational numbers, we try to rationalize the irrational numbers. Alright, so the irrational numbers on top, so we have to rationalize the numerator. What do? We always times the conjugate. We times exactly the same thing except the sign in between. So we times square root of 1 plus 2x plus square root of 1 minus 2x, up and down, so that we are actually times 1. Alright, so when we times the square root of 1 plus 2x, it becomes 1 plus 2x. Then minus, plus, so eliminate their own. And then negative, positive of square root 1 minus 2x times together, we get negative 1 minus 2x. Down here, x times the irrational numbers. So we don't expand it, okay? We leave it by x times square root 1 plus 2x plus square root 1 minus 2x. Then we try to substitute the 0 inside, okay? So we get 1 plus 2 times of 0 minus 1 plus 2 times of 0. So we get 4 times of 0, okay, divided by 0 times 1 plus 1, right? So we still get 0 divided by 0. But we can see we are actually getting 4x divided by x times the 2 square root, right? Then we have common factor, which is x and x. There we get 4 over square root of 1 plus 2x plus square root of 1 minus 2x. Now, when we replace the x by 0, we get 4 over 1 plus 1, which is 4 over 2. Then we get 2. B. The limit of 3 minus square root of square root of x plus 5 divided by x minus 4. So when we do substitution of 4 inside, we get 0 over 0. So we try to rationalize the numerator because we see irrational number here. So we times the conjugate. So 3 minus square root of x plus 5 times with 3 plus square root of x plus 5. Up and down, so that we are actually times 1, right? Then 3 times 3 we get 9. 3 times positive and minus times 3, they are eliminating each other, and negative positive square root, I'm actually getting x plus 5. Down here we get x minus 4 times the 3 plus square root of x plus 5. So we leave it like this. Okay, so simplify on top of the numerator. So we get 4 minus x as the numerator, and down here we get x minus 4 times 3 plus square root of x plus 5. 4 minus x and x minus 4, they are actually common factor, and this is negative 1. So we get negative 1 over negative 1 over 3 plus square root of x plus 5. Now we try to substitute the x equals to 4. So we get negative 1 over 3 plus square root of 4 plus 5, which is 9. Then we get negative 1 over 3 plus 3. Then I get negative 1 over 6. C. The limit of x squared minus 5x plus 6 over 2 minus square root of x plus 1 when x tends to 3. So now we see the denominator is now irrational. So we try to rationalize the denominator, right? So x squared minus 5x plus 6 times the conjugate of the denominator. So we get 2 minus square root of x, we should times with 2 plus square root of x plus 1 and 2 plus square root of x plus 1. So for the x squared minus 5x plus 6, we can actually factorize it by x minus 2 times x minus 3. Then only we times the conjugate. So 2 plus square root of x plus 1. Down here, after rationalize, we get 4 minus x plus 1. So let's see whether we have common factor. 4 minus x plus 1, we get 4 minus 1, which is 3, minus x. So we get 3 minus x. So we see this is the common factor and differ by negative 1, right? So now we have only x minus 2 times negative 1 times the 2 plus square root of x plus 1. Try to substitute the x by 3. So we get negative 3 minus 2 times 2 plus square root of 3 plus 1, which is negative 1 times 2 plus 2, which is 4. So we get negative 4. Question number 4. it is given that limit of x squared minus k over 3x minus 6 when x tends to 2 equals to 4 over 3. Find the value of k. Okay, so to find the value of k, we see x squared minus something, okay, and over 3x minus 6. So if we substitute the 2 inside, we get 4 minus k over 6 minus 6, which is 0. So we can guess that, okay, this is actually something of 0 over 0. Okay, so we need to do factorization and cut off the common factor, right? So we try to factorize out the 3x minus 6. We get 3 times of x minus 2. So this must have a common factor with x minus 2. So I roughly guess that x squared minus k equals to x plus 2, x minus 2. Alright, so I can know that I will get x squared minus 4. So the k is actually equals to 4. Alright, you can have a check, okay, when we put limit when x tends to 2 of the x squared minus 4 over 3 times of x minus 2, right? X tends to 2, x plus 2, x minus 2, and 3 times of x minus 2. Will we get back 4 over 3? So we can substitute the x by 2 divided by 3. So we will get back 4 over 3. So therefore our answer is correct. B. The limit of x squared minus 2x minus h over kx plus 2 when x tends to negative 1 equals to negative 2. Find the value of h plus k. This one will break it a little long, okay, because we have unknown here. If we substitute the negative 1 for x, we get 1 minus 2, 1 plus 2 minus h, which is involved unknown. Alright, and then down here as the denominator, we get negative k plus 2. It involves unknown, so we cannot make sure that it will be 0 over 0, right? If this happens, okay, then we can know that on top the numerator equals to 0, we'll get h equals to 3, and the denominator equals to 0, we'll get k equals to 2. So the h plus k equals to 5. But what if, okay, it is not in this case? Alright, it can be this 2 is after simplify, okay, I will get negative 2. Okay, so I will prefer to do it this way. If we can sub in the negative 1 directly, alright, directly, so we get negative 1 squared minus 2 times of negative 1 minus h divided by k times negative 1 plus 2. I will get back negative 2. Okay, I did not cut off anything because it's not from 0 over 0, right? Then I will get this one, h plus 2k equals to 7. So in this case, alright, in this case means that this fraction is actually give me negative 2. So it can be 2 divided by negative 1, just like this. The numerator equals to 2, denominator equals to negative 1. So I will get h plus k equals to 4. Or I can get 8 divided by negative 4. So the numerator equals to 8, denominator equals to 8. Denominator equals to 4, equals to negative 4. Then we'll get h plus 1 equals to k, and so on. Alright, we have so many cases, so many different answers. So I agree with all these answers are acceptable. The condition is when we replace back inside, okay, the h and k, it will always fit to h plus 2k equals to 7. So 1 plus 2 times of 3, I'll get 7. So this can be the solution. Or negative 5 plus 2 times of 6. So I will get 7 as well. So this can be my solution as well. And try on this. When h equals to 5 plus 2 times of 1, I will get 7 as well. So this one can also be my solution. So it actually have quite a number of solutions. You can try to list down by your own. Number 5. Differentiate the following functions with respect to x by using first principle. A. Y equals to 5x minus 8. So, to use first principle, the concept is we have 2 points, point x, y, and the other point that is very near to this point, which is x plus del x, and the y plus del y. So we are finding gradient from these 2 points, which is y, the gradient equals to y2 minus y1 over x2 minus x1. Alright, so let's see. Okay, so when y equals to 5x minus 8, the y replaced by y plus del y, x replaced by x plus del x. Okay, so we get y plus del y equals to 5 times of x plus del x minus 8. So after expand, we get y plus del y equals to 5x plus 5 del x minus 8. Then we need to find the difference between the two equations, right? So we use second equation to minus the first, so that y minus y becomes 0, and del y minus nothing, we left only del y. 5x minus 5x, we get 0. 5 del x, I have no del x here, right? So we left only 5 del x. Negative 8 minus negative 8, we get 0. So we get del y equals to 5 times of del x. And we're trying to get dy dx, which is nearly to del y over del x. So we move the del x to become divide, and the right hand side left only 5. So we know dy dx is actually the limit of del y over del x when del x tends to 0. So del y over del x is 5. Then when del x tends to 0, for the limit of 5, we get only 5. B. Y equals to x squared minus x. Then we try to get second point, y plus del y. X become x plus del x. X become x plus del x. Alright, so after expand the square minus the bracket, okay, so we get second equation. Then the second equation minus the first equation, we get y minus y, del y, nothing, right? So we get only del y on the left. X squared minus x squared, 2x del x plus del x squared, okay, then minus x minus minus x, negative del x minus nothing, so we left only 2x del x plus del x squared minus del x. All involve del x, we can factorize out the del x, become del x times 2x plus del x minus 1. And move over the del x, we get del y over del x equals to 2x plus del x minus 1. dy dx equals to the limit of the del y over del x, which is 2x plus del x minus 1, for the del x tends to 0. So when del x tends to 0, we get 2x plus 0 minus 1. So dy dx equals to 2x minus 1. C. Y equals to x plus 1 squared. So the y equals to x plus 1 squared, I will expand the y. So y equals to x squared plus 2x plus 1. Then the second point would be y plus del y. equals to x plus del x squared plus 2 times of x plus del x plus 1. So expand, we get y plus del y equals to x squared plus 2x del x plus del x squared plus 2x plus 2 del x plus 1. Again, second equation minus first equation. We'll see we left only del y equals to all this del x involved, the rest eliminated with the original y. Right? So factorize the del x. Okay, we get 2x plus del x plus 2. So del x move over, we get del y over del x equals to 2x plus del x plus 2. So the dy dx is the limit of 2x plus del x plus 2 when the del x tends to 0. So we get 2x plus 0 plus 2, which is 2x plus 2. D. For a reciprocal function, y equals to 1 over 4x. So the second point will be y plus del y equals to 1 over 4 times of x plus del x. Then, second equation minus the first equation, so that y minus y 0, we left only del y on the left. Then we have fraction minus fraction. Okay, no worry about the fraction minus fraction. Okay, when we see fraction minus fraction, always back to basic. Make the denominator same. So we already have common factor of 4. Alright, so for the first fraction, I only times x up and down. The second fraction, I will times x plus del x up and down. Then I have my common denominator, which is 4 times x plus del x. Alright, then for the numerator, I get x minus x plus del x. So after simplify it, we get negative del x over 4x times x plus del x. So if we want del y del x, we move the del x over. Okay, we left only negative 1 over 4x times x plus del x. The dy dx is the limit when this del x tends to 0. So when del x tends to 0, so we get negative 1 over 4x squared. So this is the dy dx. Number 6. The displacement of a squirrel running on a straight cable for t seconds is given by st equals to t squared minus 3t, where t greater than equals to 0. By using first principles, find the velocity of the squirrel when t equals to 5. So we need to find velocity, which is derivative of the displacement to time with respect to time. So it's actually the difference of displacement divided by the difference of time, right? So from the st equals to t squared minus 3t. Okay, then the second point will be st plus del s equals to t plus del t squared minus 3 times of t plus del t. So the s plus del s equals to t squared plus 2t del t plus del t squared minus 3t minus 3 del t. So I have two equations, and the second equation minus the first will get del s on the left equals to t squared minus t squared gone, 2t del t plus del t squared, negative 3t minus negative 3t gone, okay, and then minus 3 del t. And we can factorize the 3 del t out. So we get del s equals to del t times 2t plus del t minus 3. So del s over del t equals to 2t plus del t minus 3. the dy ds dt equals to the limit of 2t plus del t minus 3 when del t tends to 0. So we get v actually equals to 2t minus 3. The end.